Steelworks are a complicated activity in construction, although reinforcement is important for the structure. Learn more about standards and materials estimates here in quantity surveying. Preliminary estimates for steelworks are computed by weight, thus a table is provided to assist us with the weight of reinforcement required. Although computations will be per diameter and we are to find the number of pieces, to avoid a long list of various sizes, estimates are summarized into kilograms so the column of per meter length is provided. Besides computing the required length of rebars per member, there are still additional lengths which we can categorize as development lengths. Such are from the bends or hooks used depending on the member. Commonly, the bigger diameter bars would use bends as it would be more difficult to create hooks from them. And needless to say, with the same reason, the smaller diameter bars can be fabricated with hooks. The development lengths are added to ensure that each member of the building will be properly integrated or connected, such as that of the beam with the column. For bends, the development length is taken as 12 times the bar diameter. The hook, on the other hand, is measured as the bigger between 4 times the bar diameter or 2.5 inches. Another addition to the estimated length of the reinforcement is the splice length. There are different ways to connect each bar. One is by tying them with a tie wire, and this is the most common splicing method in constructions until today. The others can be through welding, and the higher structures can also use couplers for the joints. The splice length is computed as 50 times the bar diameter. So for a 20 mm diameter bar, the splice length is measured as 50 times 20, or that would be 1 meter. Direct counting in estimation is ideal, and here is an example on how to do just that. Let's say that we are to estimate 9 footings of dimensions 1 meter by 1 meter with thickness of 0.4 meters. Each footing's rebars are 6 diameter 20 millimeters on centers both ways. If we illustrate each footing, we can see that there are 6 vertical bars and 6 horizontal bars on each footing. Thus, there are 9 times 12 for the complete foundation, which requires 108 pieces. The next thing to consider is the length of each piece, so by drawing the cross-section, we can identify the length as the width of the footing less the 2 sides of concrete cover. And for a footing, a concrete cover of 3 inches or 0.075 meters is standard. And then, the length will be with the bend of the bar on both sides, so that is twice of 12 times the bar diameter, which is 20. And in computation, 1 meter less twice of 0.075 plus twice of 12 times 20 will result to 1.33 meters. So we are to prepare 108 pieces of 1.35 meter length of D20 bars. Since we are to convert the estimation in weight, note that for a D20, a standard weight per meter is 2.466 kilograms, as written on the table. So the total weight is computed as 108 times 1.35 meters with 2.466 kilograms per meter, giving the total weight of 359.55 kilograms. The case of footing seemingly is the only one where direct counting may be easy. For other construction activities, estimation is adopted. For example, if we are to estimate the steelwork in walls, there are two ways to do the job. One is area method, where we need to compute for the wall area and then use a table to compute for the rebars. The other is unit block method, where we compute for the number of CHB before using the table to estimate the reinforcement. Such table used for both methods is the one presented. Note that this table contains the two methods which would result to the length of bars for the walls. One is per block and the other is per area. The table is divided into vertical and horizontal reinforcement. For vertical bars, the standard spacing for CHB walls range from 40 cm to 80 cm. The horizontal reinforcement varies from 2 layers to 4 layers. Here is an example for estimating rebars for a wall of 5 meters length and 3 meters height. There is also an embedment of 2 layers. 10 mm diameter bars are to be used for reinforcement, and they are to be placed vertically every 0.4 meters on centers and horizontally every 3 layers. To illustrate, the wall will somehow look as follows. Let's estimate the rebars first using area method. The area of the wall is computed as 5 meters by 3.4 meters, including the 2 layers embedment, and that results to 17 square meters. With the vertical reinforcement spaced every 0.4 meters on centers, the table shows a factor of 2.93, thus total length of bars needed for vertical reinforcement is 17 square meters by 2.93, and that is 49.81 meters. The horizontal reinforcement is computed similarly, as the table shows 2.15 factor for 3 layers. So 17 meters by 2.15 is equal to 36.55 meters, and this is the total length of D10 bars for horizontal reinforcement. Finally, we can take the total length of D10 rebars for the wall as the summation of the vertical and horizontal reinforcements, and that would be 49.81 with 36.55, giving the total length of 86.36 meters. Such length can be then converted into kilograms by multiplying it to the unit weight of 10 mm bars, which is 0.617 kilograms per meter, and that would give us the total weight of 53.29 kilograms. The next method to showcase the example is through block method. And instead of just the area, we are to determine how many concrete hollow blocks are required for the wall, so the area is multiplied by 12.5, which requires 212.5 pieces of CHB. Now for the vertical reinforcement. A factor of 2.365 is used for 40 centimeter spacing. Thus, the total length of vertical reinforcement is 212.5 multiplied by 0.2365, which is 50.26 meters. Continuing the estimation with horizontal reinforcement, the table reflects 0.172 for 3-layer spacing. So the wall requires 212.5 times 0.172, which results to 36.55 meters for the total horizontal reinforcement. So the total length of rebar for the block method is computed as 50.26 plus 36.55 meters, which would be 86.81 meters in total. Using the 10 mm bars with unit weight of 0.617 kilograms per meter, the total weight is computed as 53.57 kilograms. Tie wire is also an essential material in steelworks as it is used to bind the bars. A roll of tie wire usually weighs 40 to 45 kilograms, and such weight can be around 2,285 meters length. So by computation, we can say that a kilogram of tie wire can produce 53 meters. In the construction site, the length of tie wire also vary from the thickness of bars they bind. 25 centimeters tie wire length is used for thin bars of diameters 10 to 12 millimeters, and a longer length of tie wire is used, that is 30 centimeters, to bind the thicker diameters starting from D16 RSB. To showcase the computation for tie wire, let's continue the example of footings previously. With 6 D20 on centers both ways, we can compute the number of intersections as 9 footings with 6 by 6 intersections, giving a total of 324 intersections. As we are tying D20 rebars, we will require a length of 30 centimeters tie wire, so the total length is computed as 324 by 0.3, or that is 97.20 meters. Now let's convert this length into kilograms of tie wire, so we multiply it with 53 meters per kilogram for gauge 26 tie wire, and that would be taken as 1.84 kilograms.